Good morning, everyone. So today we'll be starting with the next topic, that is pointers in C. So as part of this topic, uh, we'll be covering some subtopics. So for today's lecture, the subtopics are introduction to pointers, then pointers and functions, and pointers and 1D arrays. So we will look at these topics one by one. So we'll start with understanding what exactly a pointer is. Okay. So what is a pointer? We have already seen this earlier. So it's a revisit, right? A pointer basically is a special variable which can hold the address of another variable. Okay. So so this is a special type of a variable which is capable of holding the address of another variable. Okay. So how do you declare it? So the syntax for declaring a pointer is making use of the star operator. Okay. So this, so it is data type. As you declare any variable, you have data type followed by the variable name. Okay. But since it's a special variable, so there's a star, the asterisk symbol. So data type followed by asterisk symbol followed by the pointer name. Okay, so this is the syntax for declaring a pointer. Now, to give an example of this, if I want to declare a pointer to an integer, then I say int star followed by the pointer name, say it is p. Okay. Now I said that this variable is a special variable, it can hold the address of another variable. Okay. So for holding the address of another variable, so I am sure you're aware of the address of operator, which I have also talked about in many of my earlier lectures, the address of operator. So if I have a variable called a, so suppose I have a variable, integer variable a, okay, and I want to access the address of a, or I want to find out what is the address of a, where in the memory is a located, then I can make use of the address of operator. So I say address of a. So this expression is going to give me the address of a. Okay. So a pointer can hold the address of a. So pointer, if I want to assign some value to the pointer, the value will be an address. So I write the expression p is equal to, p is my pointer variable. I say p is equal to address of a, right? So this is how I initialize a pointer variable. Okay. Now, suppose a is having some value 5. Okay. And I want to print the value 5 using this pointer p. Then I use another operator. Okay. So this is the address operator, address of operator, right? So if I want to access, now I want to access the value of a using the pointer variable p, then in that case I make use of the indirection operator or the dereferencing operator. So this is also known as, this address of operator is also known as the reference operator. Okay. So if I want to get the value of a via p, I make use of the expression star p. So this star this operator is known as an indirection or dereference operator. So I just want to explain how this works exactly in memory. So let us draw the memory map. Okay. So now both A and P are variables. Okay. So suppose P is at some locations. So since both are variables, each of these will have memory addresses, right? So suppose P is at location 1000, then in so this is P, okay, and say A is having another memory address 2000, okay. You have assigned A to 5. When I say P is equal to address of A, what happens is in P, the address of A is stored. Okay, so this value 2000 will now be stored in P. Okay, now if I say, if I write the expression P, if I write the expression P, then what will be printed out? What will be printed out? This value, the value of the variable. It's a variable, right? P is a variable. So if I write the expression P, what will be printed out? 2000. For example, just to correlate, A is a variable, right? So if A is a variable, if I just write the expression A, if I write the expression A inside printf %d A, what will be printed out? 5, right? The expression A will give me 5. Similarly, the expression P is going to give me 2000, right? Because that is the value of P. Now I want to, if I write this expression, address of A, so this is going to give me 2000, right? If I write the expression address of A, what should I get? I should get 2000,
2000.
right? So P and address of A, these two expressions are equivalent. P is the same as address of A because I have already made this assignment here in this statement. Okay, so that is why both are the same. Now I said I can refer to the value of A using P. So how do I do it? Using the indirection operator. Okay, so this expression star P, whenever I write a star before a pointer, I replace this pointer with the actual value that it has. So what is the value of P? It is address of A, right? So I just replace it. Whenever I put a star before P, I break down the expression into star of, and I replace this P with the actual value of P, and that is address of A, right? So I replace it with the value. So star of address of A. Now this is the reference operator and this is the dereference operator. So these two cancel out and you are left with only A. Okay. So star P in effect is nothing but A. So the expression star P and A, they are equivalent. Okay. So this is how you access the value of a variable using a pointer. So this concept, I think earlier it must have been covered because you have already done one swap function. So what I will do is simply I will just show this program. Okay. So in this program, we will actually print out the values of these expressions. Okay, so here there are two variables, one is an integer, one is a float. So if you want to actually have a pointer, then the type is important. Okay, so when I say int star pn, this pn is a pointer to an integer. Okay, and if I say float star pm, then it is a pointer to a float. Pm is a pointer to a float. So an integer pointer or pointer to an int can hold the address of an integer only. That is important. And the pointer to a float can hold the address of a float only. So you are not allowed to have mismatch of types. Okay. So the same example that I discussed, it's just you're running the program. So if you want to actually print the address, what is the placeholder that you can use %p, you can use %x, %p for pointer, you can use %x for hexadecimal, you can use %u for unsigned int. So since addresses are having absolute values, so positive values, they're positive integers, they're unsigned integers, right? So you can use %u, any of these in the placeholder. Okay. Now if I run this example, so my variables have are m and n. One is an integer, the other is a float. Okay, and then what I've printed is the address of n, the address of m, and then I've printed out pn and pm. So pn and pm are going to give me the addresses, because here I've made the assignment, right? So this expression and this expression are same, right? Pn is the same as address of n, and pm is the same as address of m. They are equivalent. So it is printing out the same address, you can see. And also, if you want to print out the value of these variables using pn and pm, you can make use of the dereference operator. Okay. If I want to add the two numbers, also I can add using the pointer notation. So for adding that, I simply write the expression, the same expression, but instead of n plus m. So instead of n plus m, what will I do? I will replace n by the pointer equivalent, that is star pn and star pm. That is what I am doing. And if I print the sum, I'll get the same answer as n plus m. Right? So it will give me 7 plus 7.5. Okay. So this is a short example of pointers and how to initialize pointers, how to dereference the pointers. Okay. So next is, before we start with pointers and functions, I just want to make a note about a special value of a pointer. Okay. So if I have in my program a pointer, any pointer p, okay, and I don't actually make it point to, I don't point it to some variable's address, then in that case, this p is going to contain a garbage value. P is going to contain a garbage value, right? A variable which is declared and it is not initialized, then it contains a garbage value. And you know, when you have such a variable and you forget to initialize it and then you try to use it, then there could be problems. Okay. So similarly with the pointer also there's a problem. So what do you do is, how do you initialize? So you can say, whenever I say int a, I say int a equal to 0 initially, some initial value I give, right? So for the pointer, there is a special value if it does not point to any address. That is, if it is uninitialized, rather than keeping it as garbage, because garbage is going to be dangerous, right? So you have a special value, and that special value is called as a null value. Okay. The null value is a constant which is defined as in the C, as part of C, and that constant is 0. So what you do is, if you don't want to use it for now, initially you simply say int star p is equal to null. Okay. So it is this null. When I write this expression p becomes a null pointer. P is called a null pointer. What is the meaning of a null pointer? What is the meaning of a null pointer? It is not pointing to any address. P is not pointing to any address, right? And what is the use of it? What is the use of null point, making a pointer null? To avoid program crash. right? Because uninitialized variables are dangerous. They might crash your program later on. So to avoid that, you make use of this special null value or null pointer. Okay. So this basically is one note which I wanted to make before I start with pointers and functions. What happened, Janvi? Any doubt? Any doubt?
No, ma'am. No, ma'am.
Okay, you raised a hand by mistake, I think.
No, I didn't choose.
Someone raised a hand by mistake. Okay, anyways, let us move on to the next part, that is pointers and functions. So when we say pointers and functions, okay, since a pointer is a variable, pointer is a variable, right? So it can be passed as a parameter to a function. So pointer can be a parameter. Okay. Since it is actually a new type, okay. So int is a type, but int star is also a type because it's a special type, right? It's a pointer type. Okay. This is an integer. This means an integer. And this means a pointer to an integer. The type that I'm talking about. Okay. So since pointer is a type as well, you can also return a pointer. Okay. You can return a pointer from a function. You can have a pointer as a function parameter. You can also return a pointer from a function. Okay. Now, what is the use of this, you will ask? So the use of this you have already seen in a classic example, that is the swap function. Okay. So we can actually simulate. So what is the swap function? You sometimes in functions, from a function, you want to access the variables in another function and modify those variables. Okay. What you want to do is you access from a function, access and modify. You want to access and modify the variables of another function, right? That means whatever changes you want to make in that other function should be from within this function, right? So if you use the usual mechanism, that is what you simply have an integer parameter which is passed or a float parameter which is passed, then in that case what happens? In that case, a copy of that parameter is made in the function, right? So whatever changes are made inside this function, those will not be reflected outside the function. They'll be local to the function scope. If you are making any changes to some variables, because it is not happening. Why? Because a copy is made, and the copy is inside this function. Nothing is happening to that other variable which is in that other function from where this function was called. So when I'm talking about swap, my function calling function is main. Is a calling function from where I'm going to call swap, right? X comma y, whatever. So if I pass it as normal integer parameters, then what will happen? Those changes will not be reflected inside main. I'm not able to modify x and y from main directly through swap. So if I want to do that, I need to be able to access the address of those variables. I need to be able to access the address of x and y. Only then can I make the change now. So what I do is, instead of passing the integers directly, I pass the addresses of those integers. So if I want to call swap, I need to pass the addresses of x and y. Okay. And if I have the addresses of x and y now inside swap, I can easily modify those whatever is there at those addresses, right? From inside swap. So if I have because what is happening now, I have the access to the address. So that address, whatever is that there at that address, that I'm modifying directly. So that is the idea behind using pointers as parameters. Okay. So let me switch to that program. Swap pointers. Swapping two variables using pointers. Okay. So how do you write the call? Swap address of x and address of y. So inside swap. So how will the prototype change now? It was integer first, int comma int, because whatever you were passing were integers. But now it has changed to int star comma int star, right? So inside swap, I have two pointers now, because only pointers can hold addresses. You got it? You are passing addresses of x and y inside swap in the function call in line number 10 here. But in order that I have addresses, the variables that can hold addresses, they should be pointers. So that is why in the signature it have the variables are pointers. So int star a star b, int star b, right? And then what you do is you simply say temp is equal to star a. Wherever there was an a, you will write it as star a. Star a is equal to star b, and star b is equal to temp. If you're using a normal variable, then if you're using an integer variable. But if you're using a pointer variable, then you have to do this kind of an assignment. Are you understanding why I have written it this way? Or no? Tell me. If I write this, the same thing using T1 is an integer variable. What will be the change that that will be there in this program?
Just T1 instead of star T.
Wherever there is a star T, it will be T1. Okay. Now what I have done is I have made that also as a pointer. So if I make that as a pointer, then I need to hold make it point to some address. Okay. So I say star T is star A. Okay. Star A is star B, and then star B is equal to star T, if I'm using this way. Okay. So this is about the swap function, which you have already seen. This is just a recap of the thing. So this is how pointers are useful. So let us see one more example. Now in this example, suppose you want to return more than one value from a function. Is it possible? Can you return more than one value from a function in C?
No, ma'am.
Okay. So returning, the second use is returning more than one values. Returning, say, two values from a function. Okay. This can be done by making use of pointers as one of the parameters. For example, you have a simple toy example. You have the radius of a circle. Okay, and you want to calculate two quantities, the area and the circumference. Okay, So the usual way in which we write this is we have two different functions, one for area and one for circumference. Okay, but now I say no, modify this approach. I want only one function to compute both area and circumference, but not only compute. It's easy to compute. I can just write a printf statement then, a printf %f area and %f circumference. That is fine. I don't want that. I want the values back in the calling function. Okay. So I'm just saying modify this problem now, this solution now, and give me only one function which is going to return these two values to the calling function. So now this cannot be done in a usual way. So what we do is we pass one. So let us call this function as compute. This function, one value will be a one of these quantities. Let us make this function return one of these quantities via the return statement. Okay, and of course, what is the input data that it is working on? It is the radius. Okay, and the second quantity that is to be computed, let us make it a pointer. So let us say float star c. So what do you understand by this? When you are writing a main function, when you're writing the main function, what will you have? You will have the radius here in float radius, right? Float radius. Inside the main function, of course, you will read radius and all that, and then you will call this function. So you will have the area as one parameter, as one of the variables, and circumference as one of the variables here also. So what you will do is, to this function, if you want to call this function, what you will do is, you will say the call will look like this. A is equal to, because what I am expecting from the function to return, it's going to return the first quantity, that is area. This function is going to return area. Okay, so the call should be A is equal to compute radius, comma, the second quantity. What I will do is, I will just pass the address of C here. So what will happen? Let me give this another name so that
The
let
actual
me call this PC.
circumference will be put at the address of C.
Yes. So when the function prototype is this, so this happens, right? ऐसे होता है. Assignment कैसे होता है? R is equal to rad, because these are the formal parameters of the function. So R के अंदर rad आ गया, and inside PC you have address of C. Now using PC, can you modify C? If you are making any changes, if you are saving the value of the area, value of the circumference, that computation in PC, that means via PC you can save it in C. I can say star PC is equal to that circumference 2 into pi into r. I can write this, huh? When I say star PC, what do I mean by that? C is equal
The
to
value
2
at
into,
address of C.
yes. So this expression is the same as this. Star P is the same as star PC is the same as C.
Yes, ma'am.
So this is equivalent. So instead of C, I am going to use the expression star PC. Okay, so that is the idea of returning multiple values from a function. So if you want to return multiple values from a function, the function can return at most one value. But for the additional values, what will you do? For all those additional values, you will make all those parameters as pointers. Are you getting it? So if you want to return 3 values, then 2 parameters will be pointer parameters. Are you getting it? Okay. So this is the function, the same function just written down. First parameter is the radius. Second parameter is you're just passing the address of the perimeter, this parameter here, and star pp, and then you simply wherever that expression you just use star pp. Okay, and you're returning area. You're returning area, but the perimeter is getting saved. It is getting modified. This variable p is getting modified via pp. Okay, so that is the advantage of pointers. So this example, I run this, radius is 10. So area it is giving, and the perimeter is also it is giving, correct? 2 pi r. So that is how you can make use of that. That is yet another use of pointers. Okay. Now, third is you can also return a pointer from a function. How to return a pointer from a function? The return type of function can be int star or float star. It can be that. Okay. That is the meaning of returning a pointer from a function. So to understand this, let us see the example. You want to find the minimum of two numbers. Okay. So to find the minimum of two numbers, you are going to use a pointer to return the minimum number. You are going to return a pointer to the minimum number. Okay. So what you will do is, there are two ways of doing it. That means there are two signatures which are possible. So I've written both. Let us see the first signature. First signature says this one, line number 5. Your find min, the function name is find min. What you're doing is those two numbers, you are passing the addresses of those two numbers. So accordingly, what will be the prototype of the function? It will be float star, because the numbers are float numbers. Okay, x and y, they are float numbers. So I'm going to pass the addresses. Okay, so in that case, this is the first variable. So in that case, how will you write this function? Huh? You have to give the body to this function. You will say, if star A is less than star B, you are going to return A. Otherwise, you're going to return B. This is a simple logic, right? Which of these two numbers is smaller? So how do you access the numbers via pointer? Star A and star B. So if star A is less than star B, return A. Otherwise, return B. You are not returning star A, remember. You're not returning a value. You are returning a pointer. Okay. So you're returning A only. That means that address, the address of this variable X, you're returning. Okay. Otherwise, you're returning B. Okay. So return type of this is float star. So how will I call this function inside main? The function call will be find min. You are passing the addresses of X and Y, the two variables. And there is one more variable, which is a pointer variable. That is float star min. Okay, star min. So min is equal to look at the call. The call is on the left hand side is a pointer, right? Min is equal to find min, address of X, address of Y. What is find min going to return? It's going to return an address. A is going to contain an address, right? A is a pointer. If I write expression A as it is, what is the meaning of that? It's an address. It is going to contain address, right? So how to call it? Min is equal to address, that address. So min will be having finally either the address of X or the address of Y. Do you agree with this? When I run this program, min will either have the address of X or it will have the address of Y. Yes or no?
Yes, ma'am.
So this is one way of doing it. What is the second way? These two parameters, I'm just keeping them as it is, the normal integer parameters. But I'm making this function return a pointer. So what will you do is, inside this function, this you create one more parameter, one more variable, that is a pointer variable. In the function, you are creating the pointer variable. So in the function, you are creating a pointer variable p. So look at the change. P initially it is null. Okay, just safe, playing safe. Then if a is less than b, if a is less than b, then what you're doing? You're assigning p to a's address. Are you getting it? You're accessing a's address via p. So you are assigning p to a's address. Otherwise, you are assigning p to b's address. Okay, and then you're returning p. So what will this do? Isn't it equivalent to the previous one? When you say return p, p is going to actually contain the address of either a or b. And a and b in this case is a and b in this case is x and y.
Yeah.
Okay, so this is yet another variant. So there are three things that we saw with functions. First is simple call by address, you saw. Okay, that is swap function. So that's known as call by address, but it is not or call by reference, but it is actually simulating call by reference, because in C, call by reference mechanism as such does not exist. It is simulated via pointers. In C++, there is one more mechanism, call by reference, which is somewhat different from this. We'll see when we study C++. Okay, but in C, what you're doing is just you're simulating that address passing, because pointers, with the help of pointers, you're just manipulating that address value at that address. That is what you're doing. Okay, so that is the first thing. Second thing is returning more than one value from a function. That is the second thing we saw under this. And the third thing is returning a pointer from a function. Okay, so these are the three variants. Next is pointers and 1D arrays. The last topic for today is pointers and 1D arrays. Okay, we will also be seeing pointers and 2D arrays tomorrow. So first of all, let us start with pointers and 1D arrays. Okay, so this is a single integer array which is there. You know how it will look like in memory. Okay, these are my integers, right, in consecutive memory locations. When I say consecutive memory locations, what do I mean by that? Size of an integer is 4 bytes, assuming that the size of an integer is 4 bytes. The next integer is going to, assuming that each memory location can store 1 byte. So 5, this 5 will span 1000 to 1003, right? This integer will be saved across those 4 bytes, that is 32 bits. Okay, so the next integer will be saved at which location? 1004. 4 bytes each, right? 4 plus 4 plus 4 every time. So this is how it is going to look inside memory. Everyone is good with this? Everyone understands this? Yes?
Yes, ma'am.
Yes, ma'am.
So let us see now how we can relate to arrays as pointers. So arrays actually are pointers only, but they are constant pointers. So let us see. When I write the name of the array, A was my array. Now I'm writing the name of the array as it is, A. Array name written, it is a shorthand notation for address of the first element of the array. It's a shorthand notation for the address of the first element of the array. Okay, that means this expression is the same as address of A of 0. Everyone knows about this, right? So this expression, address of A of 0 or A, is going to give me 1000 in this case. When I try to print this out, it's going to give me 1000. the address of the first element of the array. Okay. If I say address of A of 3, if I write the expression address of A of 3, what is it going to give me? 1012. Okay. Now I can write the same expression as what is written on the right hand side, that is A plus 3. A plus 3. Why? Why? When we add an integer to an address, the calculations are with respect to memory address. So first of all, let us just break this expression down. So what is A plus 3? What is A? First of all, let us replace A. A is nothing but address of A of 0. Right? A is nothing but address of A of 0 plus 3. So the expression has now become this. Yes or no? So you're adding 3 to this address. You're adding 3 to this address. So whenever I write this, some constant integer is added to an address, then what does it mean? It means that you are adding those many addresses to the original address. Those many locations, basically, those many locations to the original address. So this expression is actually calculated with respect to memory addresses. So A plus 3 means 3 memory locations are added to the address of the first element of array. Okay, so that means I'm going to start with this address. Okay, then I'm going to add one location, I jump here. Then I'm going to add one more location, I jump here. And then I'm going to add one more location and I jump here. So I get this address. So it's not just 3 value integer 3, it's 3 memory addresses which are added. 3 locations, 3 memory locations are added. 3 integers. 3 integer addresses are added to address of A of 0. Okay, so that is what is explained. How do you compute it mathematically? It is 1000 plus 3. 1000 plus 3 is now 1000 plus 3 into 4, because each integer is 4 bytes. So that kind of a calculation actually happens in the background when you write this expression A plus 3 or address of A of 0 plus 3, both are equivalent. If you write this, okay, what happens is 1000 plus 3 into 4, that is 1012, and that is how you get 1012. Okay. Now if I want to write A of 3, if I want to get A of 3, I can write the same expression as star of A plus 3, because arrays are pointers. So I use star expression. Now what is this star of A plus 3? Star into bracket A plus 3. So simply what you do is previous address you get, right? This expression A plus 3 is the same as address of A of 0 plus 3, that is 1000 plus 3. 1000 plus 3, that means the memory address 1000, you are adding 3 integer locations, that is 3 into 4, 1012, and you are writing star of 1012. You are writing star of 1012. That means you are trying to dereference what is there at this memory location, right? And what is that? That is nothing but this value. Star means dereferencing. You're getting the value at that location. So A plus 3 gives the address. Star of A plus 3 gives you the value at that location. Is this clear to everyone?
Yes, ma'am.
Okay. So in general, if I want to access the ith element of the array, if I want to access the address of the ith element, the expression will be A plus I, address of the ith element. And if I want to access the value at the ith location, then the expression will be star of A plus I. They are same. This is address of A of I and this is A of I. Are you getting this? This is same as this. This is same as this. Okay. Now, arrays are constant pointers. That means that you cannot do any update operations on array. addresses. That means a plus plus a minus minus is not allowed. Okay, these are not allowed. Why? Because arrays are constant pointers. You cannot update a constant value in C. If you have a constant, you cannot update it. Okay, we have not looked at the constant type, which is also available, const type keyword, but a constant pointer cannot be updated. It's static. Once a memory address is allocated to the array, it's done at compile time. You cannot change that address of that array. Okay. So next is one more example. In this example, what is seen is the array is there with you, and now you're creating an integer pointer to an integer, and then you're assigning it to the first location of the array. Can you see in the second expression? Integer int star my grade. So this is a grade list array which is having the grades, and there's a pointer to an int called my grades, which is pointing to grade list. When I say pointing to grade list, what is this expression on the right hand side? It is the same as grade list of 0, right? Address of grade list of 0. So what you have done is by this assignment, you're making this my grades point to the first location of the array grade list. Okay. Then you have two more pointers, P1, P2. P1 is pointing to grade list. P2 is pointing to grade list plus 4. These are valid expressions, right? So this is pointing to the first location of the array. Let me write the indices so it becomes easy. P1 is pointing to which location? This location, address of this location, A of 0. P2 is pointing to grade list plus 4. So what should it be? This location. P2 is pointing to address of this location, right? Now, I can write this kind of an expression. I can subtract two addresses. What will I get? P2 minus P1. What will I get? If I subtract, these are two addresses, right? P1 is an address, P2 is an address. If I subtract these two addresses, I will get 4, right? Just look at the right hand side of this these two expressions. Grade list plus 4 minus grade list. I'm going to get the integer 4. So I'm going to get how far they are from each other. How far P1 and P2 are there from each other within that array. So in the context of the array. Okay. If I say grade list of 1, it's going to give me 85. That's a simple array indexing, this one. Grade list of 1 is going to give me 85. Star of my grades, what will it give me? Now what you're doing is so you are using a pointer, another pointer which is pointing to the array. You're not using the array as a pointer. You're using another pointer which is pointing to the array elements one by one. Okay. So star my grades is nothing but address the grade list of 0. Okay. And similarly, star of my grades plus 2 will be the value at this address, grades of my grades of 2, using the previous logic that we saw. Okay. Star of my grades of 2. Okay. My grades of 3. Now this is something new. Are you getting these two? Using the pointer we are using. We are not using the array name. Look at this carefully. Array name is grade list. Using the pointer name we are using. Okay.
And P2 minus P1 will give 16. No?
P2 minus P1 will give me 4.
6. Okay.
It will not give me the difference in bytes. It will give me in integers.
Okay, ma'am. Okay.
The address calculation that I showed, that happens in the background, because in the background there is memory. As a programmer, you are not bothered about how it is saved. But that kind of a calculation that happens in the background. Because you need to compute na कि ये next element 4 bytes आगे है. So it's not on the immediate next address. It's 4 locations down the line. So that calculation has to be done internally. Okay. So now this third thing is something different. What is it? You are writing my grades of 3. Okay. So P of 3. Now this is something new. The pointer of 3. So this expression everyone knows, A of 3, or in this case it is grade list of 3. Yeah. Grade list of 3, everyone can surely say it is 88 because it's array index. Okay. Now the beauty of this is whenever I assign a pointer variable to an array, then I can use array indexing in the pointer. So instead of using the array name, I can use a pointer as an array name. So now this pointer is acting as an array. So when I use the pointer with an array subscript in square bracket, it acts like an array. So it is interchangeable. Whenever I assign a pointer to an array, I can write the same expression, grade list of 3, my grades of 3, it will give me the same answer. Okay. So this is something new which we are seeing. So pointers and arrays are interchangeable, you can say.
In the previous slide, what number was P2 pointing to?
In the previous, okay, P2. P2 is grade list plus 4, na? What?
So that would be 79.
Yes.
So ma'am, the difference is won't be 4.
Grade list, what is grade list?
The difference, P2 minus P1.
No, what is grade list?
Array.
So grade list name written as it is the address of this location. Suppose this is 1000. Okay, this is 1004. This is 1000 and I'm just taking some hypothetical addresses. 12. This is 1016. Okay.
Yes, ma'am.
So what is grade list? Grade list is 1000. Correct?
Okay.
Grade list plus 4 is 1004.
Okay.
Sorry, 1016. Yeah. 1016 because it is the address. Na? 4 addresses, 4 memory locations, 1, 2, 3, 4. So it is this. Now 1016 minus 1000 will give you 16. But 16 this is in terms of bytes. Okay, so that gets converted. You will not see this is happening internally.
Yes, ma'am.
Okay, so it will get converted, na, divide by 4 again, na. It will be divided by 4. You there in the previous case you were multiplying by 4. See here you are multiplying, है ना? 3 into 4 कर रहे थे. So here you will divide by 4. So the answer will not be 16. It will be 16 divided by 4. That is 4.
Okay, ma'am.
समझ में आ रहा है अभी?
Yes,
This
ma'am.
is clear. हाँ, अगर ये grade list plus 5 होता था, तो this would have been 1020. हाँ,
1020.
1020. So 1020 minus 1000 is 20, but 20 divided by 4 is the answer. That is 5.
Yes, ma'am.
Okay.
Thank you.
Yeah.
Got it.
So that is what. The same thing continue. These two expressions are different. Last. Look at the first example. Last is written is star of into bracket IA plus 4 star IA plus 12. These two expressions are different. Why? Because first is going to do the address calculation and then do the dereferencing, and second is going to first dereference and then going to add 12 to it. Okay. Actually, it's not. It has to be 4. I had modified this example. This has to be 4. Sorry. Okay. So the thing was why I modified this example was because both were giving the same answer, because my arrays 1 plus my array both were giving the same answer, so I modified it.
मैम मुझे 1
हाँ.
2 value 0 plus 2 होना चाहिए.
The expressions are different. See, if you dereference this first, the expressions are different. That is what I mean to say. Wait, let me write it back. I had modified this. Okay. The expressions are different. So what is the meaning of this?
Got it.
Now you have got it, huh? So more example, one more example that you see below, that is P of you can make the pointer point to any address in the array. So I say address of I, A of 2. Okay. And then using P you can subscript, right? Same, it will work like your array now. I showed in the previous slide. That is P of 1 is going to be, if I say P, if I just say P, it's going to be this location. But when I say P of 1, or if I say P of 0, it's going to be the same location. But if I say P of 1, if I write the expression P of 0, are you getting it? What will it print? P of zeros in square bracket. It's going to behave similar to the array. Okay. So it's going to give me whatever is the value at this address. That is 0, 1, 2, 3. It's going to print 3. Yes or no? P of 1 will be one location ahead of this. So P of 0 is here. P is here actually. So P of 0 is this. P of 1 is one location ahead of this. That is 4. Are you getting it? P of 1 is 4. And what is P of minus 2? I can write this negative number here. So P of minus 2 is nothing but 2 integers behind where P is. That is 1. Okay, so all these expressions are valid. Are you getting it? In the context of this array IA, are you getting it?
Yes, ma'am.
Yeah. So this is where I want to stop. Okay. And now we have 4 different examples which have to be covered as part of the lab. So tomorrow I'll be covering all 4. So that is mainly to do with 1D arrays and 2D arrays, pointers and 1D arrays and pointers and 2D arrays. So those 4 examples are based on that. So these slides I'm going to send all these examples, and of course tomorrow we'll be discussing those the questions in class, and also pointers and 2D arrays. One more thing is, this is a complete program on the same thing that was there in slides. So I'm going to give this program to you. I've commented everything because I had planned to explain it one by one, but it's okay. I think you have understood the concept. So you need to look at this. Okay. So this, you just uncomment this out. This is the same thing, arrays and pointers. So all these expressions we have written, all the different kind of expressions are possible. You run this and see for yourself how it is giving you the answer. Okay. So I will send this to you. So now you can leave.
Ma'am, I just had one doubt. Ma'am, could you go back to that last slide where you had done P of minus 1, P of minus 2? Yes, ma'am. In this, if you do P of minus 3, does it mean negative indicing?
Yeah, it will point to something which is unallocated. So you have to be careful as a programmer.
Okay, ma'am. Thank you.
You array index out of bounds is not taken care of by C.
Yes, ma'am.
Yeah.
Thank you, ma'am.